I'm Debbie Holton. I'm SME's Vice President of Events and Industry Strategy. And at SME, we focus on advancing manufacturing technology and ensuring a skilled workforce. And on behalf of SME and AMT, welcome to the West Coast's most dynamic industry event, WESTEC, where we're bringing you the future of manufacturing technology. Los Angeles and Southern California serve as the perfect backdrop for WESTEC. In fact, WESTEC has called Southern California home for more than 50 years. And this region has always been an incubator of new ideas and innovation. And as one of the largest manufacturing markets in the world, the sheer magnitude of California's manufacturing industry and innovation has a significant impact. At WESTEC this year, we've packed this program with all kinds of tremendous manufacturing knowledge and expertise, from industrial IoT and powerful analytics to additive manufacturing and 3D printing to precision machining, advanced materials, precision measurement, automation. It's all here. Please join us throughout the day here in the WESTEC Theater, at the Smart Manufacturing Hub on the other side of the show, and also at a new concept we're calling Huddle Ups, which is a great opportunity to spend some good face time with experts in particular technologies. It's all part of your WESTEC experience. We suggest that you download the app so you don't miss anything. So you can find that in the App Store, or you can find it on Google Play. Now I'd like to take this opportunity to honor a very important person to us, Marty Meshner, and one of our own. Just a few months ago, Southern California's manufacturing community lost one of its greatest contributors, a man who helped introduce thousands of young people to careers in engineering and manufacturing. Martin John Meshner, who we all knew as Marty, because that's just who he was. He achieved so much. He owned and operated Schober's Machine and Engineering in Alhambra, California. He was an adjunct professor at Cal State University of Los Angeles, where he shared his knowledge and expertise with students learning engineering and manufacturing. He was a certified manufacturing technologist, a certified manufacturing engineer through SME, and a very active SME member. He was a champion and advocate for public schools, working to strengthen their industrial and technology programs at local, state, and federal levels. Through his extensive professional network, Marty worked tirelessly to help schools find resources to save their technology programs. In his career, Marty had served as president of the Los Angeles NTMA and co-founder of the Small Manufacturers Association, the Small Manufacturers Institute, the Coalition for Manufacturing Careers, and the Century Club, along with all his SME activities. Marty was proud of helping elementary and middle school students develop their interest in technology through robotics. Working through industry partners over the course of 12 years, several thousand students were introduced to technology and engineering. Marty and his associates selflessly volunteered hundreds of weekends to produce all these competitions from Central California all the way to the Mexico border. If ever volunteers were ranked and rated, Marty would be a superhero. So Marty's charge to all of us today is to follow your passion. The fact that you're here at WESTEC, we certainly hope that it's related to manufacturing, and perhaps you could volunteer your time and energy for students and the future of our industry. We have over 650 students visiting WESTEC over these next 3 days, and I hope you're as excited about that as we are. So I'd like to just take a moment to also recognize Marty's son, who's here as well, who is able to join us. Thank you so much for being here. And I'd really just like to lead a round of applause for all the things that Marty meant to Southern California manufacturing. Thank you so much. At the crossroads of information technology and operations technology is a shift in the way we manufacture. Things are changing, and they're changing pretty quickly. We have the unprecedented ability to control, leverage, and maximize return, increasing capabilities, proliferation of data, mobile phones, mobile technology. It's really at the heart of the fourth industrial revolution. Factory automation and robotics, the digital twin, augmented reality, additive manufacturing, big data. How do manufacturers really look at all these possibilities and figure out what's right for them? What does smart manufacturing really mean? This morning's keynote speaker has 16 years of consulting experience in the areas of physical and digital operations strategy, manufacturing, supply chain process improvement, and process automation services. He is a thought leader in new business models, cloud-based services, and specializes in monetization models of new business with software as a service. Please note that after this panel, get your questions ready. I know this is really going to perk up your brains this morning. We're going to be accepting questions that can be texted to an iPad that I'll have up here for a Q&A session at the end, and it's to 22333. If you send WESTEC 17 to 22333, you'll get an activation message, and then you'll be able to text questions directly to us. So first, we're going to see a short video that's really going to get you excited about our topic today, and then we will welcome Anirban Bhattacharyya. Thank you.
We want to make a contribution in making the world a little smarter, a little cleaner, and a little safer. We deploy bearings in particular, from very small bearings with 1 millimeter to 2 millimeters diameter to the very large bearings that are used in wind turbines. In the automotive business, here we have the full spectrum from bearings within the chassis to complex transmissions up to e-axles and hybrid modules that are used in hybrid technology or in electric vehicles.
Industry 4.0 is not digitization or digitalization of mechanical industry, because this is already there. Industry 4.0 is getting the data, real-time information structure in this supply and manufacturing chain.
Our bearing of the future will be a digital-enabled sensor, in addition to the bearing standard functionalities, being part of the Internet of Things and being part of our value generation, which links bearings with more complex systems, with electronics, embedded software, as well as with additional services.
If we use IoT, if we combine this, if we use this data in a different way, we can be more flexible. So we can adapt faster, make decisions if something unforeseen happens, even in the cloud, even with cognitive systems.
We understand a lot more. We are able to build the models describing reality in the digital in a much more precise way, and allows us then to take actions on that in a way which was not known to up to now.
We created a so-called tooling machine 4.0 together with partners, and this machine has a lot of bearings where we installed sensors to measure torque, to measure temperature, measure speed. So this is important for our own efficiency, for our own improvement, flexibility. We can transfer this on a railway system. So we can check the bearing and the chassis behavior of a high-speed train. We can get in, measure when the situation gets critical for safety reasons.
We think highly about delivering customer value, and therefore we will embrace this opportunity and do it in a sustainable manner to the benefit of our customers. We are trying to embrace the whole idea of digitalization in a very holistic manner within the company by our Digital Agenda 2020 that we run systematically across the company. I believe we are complementary with IBM in that respect. We think that a true partnership between Schaeffler and IBM will guide us into the digital age and help us to shape the mobility for tomorrow.
Yeah, thank you. Good morning. Good morning, ladies and gentlemen. And thank you for attending the first session of the day. So this is the era of manufacturing automation, and the theme is consistent. There are three main themes. One is robotics and advancement of robotics. The second theme is artificial intelligence. And the third theme is machine learning. Let's add one more. That's cognitive learning. And today's topic is why cognitive matters in manufacturing, cognitive learning. And we will give you a few use cases today, how we have taken customers in the journey towards cognitive vision and also cognitive analysis, and really transform their business from, I wouldn't say completely disconnected, but semi-connected to connected manufacturing or smart manufacturing. The first step towards getting connected is having a good base of data and data collection methodology. So as we work with clients and we talk about the 4 steps towards that journey, the first step is connect the big machines to a platform, collect the data, visualize, you understand the data, and the last one is analyze. So analysis is a big piece of this puzzle. So if you really see from oil and gas industry to healthcare to core manufacturing, distribution, we are predicting when there will be a traffic jam in Manhattan, we know that. We are predicting how a disease would progress. We are predicting when a machine could stop. So the prediction is there. We are doing that work. So what's next? So great, we have prediction. So what's next? The next is self-empowerment. Well, empowerment is self, right? So of a non-living object, transforming that to kind of a living object. So human cognition into the brain of the machine. That's cognitive. And that's where I think maybe a couple of customers have really done successfully cognitive, but most of the customers and clients, industries are embracing it. And that journey from predictive to cognitive is must. It's going to happen. 2020 vision, it's going to happen. So the first step, as I talked about data, there are plethora of data sources from image data, enterprise, transactional data, tons of sensors data that are coming in. And what we are doing right now in 2017 is creating a, I'm going to use a term, creating a data economy. So why it's an economy? Because until now, I think very few industries or industry bases have really monetized it. And when I say monetized, there are 2 portions of monetization. One is soft. You're leveraging the internal data and making your processes and decision-making more smarter. And you're also selling the data to your external vendors, customers, distributors to make sure that they also make smarter decisions to fulfill your supply chain. So that's data economy. It goes to monetization level and just not you're viewing it. That's the first step towards cognitive journey, creating that data economy base. Before we get into that cognitive spiel of, okay, what's next after prediction, which is the human centricity element, machine, well, I would say cognitive learning of the machine, and more examples, let's go through a few definitions. The first one is big data. Should I say it's a cliche now, right? Everybody's using it. Big data warehousing, data machines are already available, data centers, very stable industry base. That's big data. The second one is artificial intelligence. Again, stable concept. IBM has, I think, some solid algorithms which are in the industry right now. The next one is cognitive, which is we are in that journey, and our branding is Watson, Dr. Watson, Watson, where we are trying to bring that human centricity and human element into a machine. I'm going to give an example here, right? So there is a machine which should be stopped after 350 run time. But there is an operator on the floor. He or she has to meet the sales demand unit, tremendous pressure. The person doesn't care and keeps running the machine. I mean, the machine will run. It will meet the quality. The product will go out of the door. Someday the machine would stop before its own maturity, right? So that's where the machine would start talking and say that, no, I need to stop after the 350th run. Give me a break. I will not run. That's that human centricity into the machine. So as we talk for the readiness of a cognitive system, the first step is understand. So it's both structured data. So you have a product ID and you have a customer ID. Structured data. I know what's coming in. It's structured. And there's an unstructured data also, right? Where you will take various images of nitrogen level going down in a big machine. And that you have to process that image, unstructured data, and really understand that, okay, how do I bucketize these data? Understanding of the data is important. The second one is reason. We have to have a reason for understanding and bucketizing the data. Reason is why it's happening, how the data are flowing, what the primary integration points are. The next one is learn, and that's where your machine learning comes into play. And the last one is interact, where your cognitive comes into play, because interaction only happens when a machine falls in love with a man or a woman, right? That's interaction. And that machine falling in love is cognitive. So to approach this cognitive journey, we have a method to this madness, right? So we are all predicting great models in place. Now how I take this to cognitive. It's from our experience, there are two main themes in this journey. One is performance. Performance of your supply chain, manufacturing, processes, systems, operations, new training, new hire. And the second one is experience of that performance, right? So it's about, I would say, the personification of that performance. That, yes, this is something that I can connect. It's easy to use. It's pretty much digitized and less paper, more experience. And we have three big, I would say, orchestration paths towards it. One is cognitive BDS, business decision support, BDS. Cognitive re-engineering, process re-engineering. You always have to re-engineer the process. There's a term that you can Google, you can learn, you may already know. It's coming up, is digital twin. That's the re-engineering is getting into new normals. And the last one is the cognitive process service, which is mainly your robotics coming into play and helping you out or augmenting you out. And the way we do this build process for our Industry 4.0 journey, and Industry 4.0 is a 1, 2, 3, 4. It's a fourth generation industry journey. If you want to Google it, please Google it. It's connected supply chain, connected manufacturing. It's 4.0. There are a few things you have to embrace. You have to measure yourself and be honest with yourself. So if you're in 2.5, you can't go to 4.0 immediately, no brainer. So how do you measure that? You measure through your maturity model of your processes, workers, where your gaps are, where your automation investments are needed. So there's a lot of sales and operations strategy work. Align all your existing projects. So if you have projects in place which are going on right now, you absolutely need to take a step back or step in parallel and say, okay, let me score all the projects which are aligned so that I don't need to reinvent this wheel in 2020. Define your own capabilities, where you're strong, what you want to outsource, very important. Cloud strategy, everything can be on-prem because you don't want your data to be shown in Wall Street tomorrow, right? It can be cloud or hybrid. And then the next few ones are obviously big data we talked about. Connect your device properly so that they are connected and the data flow in at the regular pace, real-time, semi-real-time, in batch process. And that connect piece is extremely important because there will be a lot of machines in your shop floor which will not have the latest technology. How do you connect that? That's the puzzle that we will be able to solve. And UI, it's IX, interactive experience, and user experience, which is the personification of the model's work that you're developing. And the last one is security. It's a big piece in the puzzle. So there's a term, it's called threat modeling. Threat modeling. Very important concept in Industry 4.0, so that in your strategy to get into Industry 4.0, you understand where your threats are, who can come in, A great example will be if you want to redefine your boundaries and you ask your vendor to create the sensors for your business, they will know your secret sauce. How do you manage that? How do you redefine the contract with your vendor? These are important things to rehash. So before we get into a few case study examples, one thing repeatedly that I'm saying is it's all about taking sensors, data analytics, information cognitive into knowledge base, knowledge curation, knowledge building, knowledge advisory, so that when you have somebody to augment you, and it's bringing a human chip into a machine, that knowledge learning is extremely important. And it takes time. So if you work in a cognitive manufacturing environment and you're as thinking to have, let's say, I would say Dr. Watson comes in and says, okay, you need to do this, and this, and this. You have to go through a knowledge curation and a playbook build. Because Dr. Watson will learn it and then he will help you. But it takes a little bit of time, and at the same time, that knowledge curation and playbook building is extremely important. And it happens. We are doing with customers right now that I'm going to share in the next few slides. So the first theme is return on assets. Return on assets. So you have assets. You want to have good understanding for the next year's strategy. You have 15 machines in place. You have 12 machines where you will invest for maintenance next year. 3 machines are kind of on the like a maturity curve going down. How do you know all these? Return on assets, right? So there are 3 use cases I'm going to share. One is, the first one is prevent production delays, because I'm improving the line performance, but on doing a good job on reducing the unscheduled downtime. So that directly affects one of the pillars of manufacturing, that is OEE, operational equipment efficiency, and improve the parts and resource allocation. Because you are proactive, you are learning what can happen. You're basically reallocating your plan for maintenance. But why it is, well, it's predictive, no brainer, right? But why it will be cognitive, or it is cognitive, right? Excuse me. Why it's cognitive? Because I was giving the example of that machine to stop itself. So now when it's unscheduled downtime, where we are going with this is, based on the history and based on the playbook learning and the knowledge, there will ideally be no unscheduled downtime. That's cognitive. Well, it sounds dream world, but that's where some of the shop floors are going. That I want to cut down completely unscheduled downtime, changeovers for unscheduled downtime. In the first use case, we are in that journey of removing unscheduled. We have done a proof of concept with this customer, and it will be productionizing this year and early next year. The next one is fault analysis. It's important too. Predictive again, no-brainer. Most of our competitors are doing it. But why it's cognitive? Because that fault analysis has a reason code, and that reason code is a learning base, right? I'm learning that out of the 7 reason codes, 1 reason code happens every month 27 times. That's huge to know the cognitive person or that cognitive Watson to know what to do. And that's where cognitive is. So fault code analysis is not only predictive, it's cognitive. And the last one is repair analysis. So as we repair machines, every time I'm repairing, it's becoming a learning for the cognitive, that Watson, Dr. Watson, he's learning it, right? So when the next repair happens, my time to repair that product is not only shortened, I may not even have to repair because there was a patch in the cloud, the machine downloaded from the cloud, if you have a cloud strategy, right? And the repair is completely self-driven, self-paced, self-healed, self-automated. Automated is self. The next theme is throughput to potential. It's mainly on the shop floor. It says operations, right? The customers of maintenance people, internal customers of the maintenance people, operations. So in these three use cases, the theme is, again, improving OEE, overall equipment efficiency, which is the base fundamental of manufacturing that we measure. Everything has to be quantified, measurable. Some qualified attributes are also there, but it has to be measured. Then only your VP of supply chain will approve the budget for next year, right? So the first one is improvement of the productivity, reduction in time. So you have a takt time for 37 seconds. You not only need to reduce it to 35 seconds, but also you need to make sure that it is completely augmented with the right reason codes, right data points, so that when you download the data later on and try to create models, you have enough information. So one of the challenges you will have, or you have in the floor, is that the takt time improvement may happen, the cycle time may improve, but you do not collect a lot of good data. So how do we do that? It's one of these customers that we worked with. We actually implemented a concept called digital process twin, where it's just on the click. It's on the click. It will actually take that information of the machine, what maintenance is being done, and take it back to ERP systems, enterprise resource planning systems. That's the first one. The second one is similar. It's not on the line, but on an inventory point. So a person, inventory manager, walking on the floor, and every morning counting $30 million inventory sitting on the floor, that's not a very pleasurable experience when you come in the morning, right? So you want to automate that process. So how do we do that? It's track and trace. Track and trace has been done by everybody. RFID is everywhere. So what's cognitive in it? So the cognitive is, when you are working on that RFID chip on the inventory and it's moving around, it is continuously learning that why there's a set of items or products or processed or unprocessed items are sitting in a buffer zone. And it's actually going back to the planner and telling that, listen, Mr. Planner or Miss Planner, it is important for you to understand that something is going wrong there, that this SKU is always carrying your most inventory cost. That's cognitive, right? So it's taking an actionable insight, telling the planner and augmenting the planner to be more smarter. That's the second use case. The third use case is a little bit outside the four walls of manufacturing, but still manufacturing, because when a product is returned, you have to make sure that you have a warranty in place or not, and how do you reduce the warranty cost? So it's, again, why it's cognitive, because 21 times it's a habit. If you have a product return coming in 21 times, so Dr. Watson learns it and says, okay, here is the problem, here is how you should fix it, and it becomes a habit. So reduction of warranty is predictive. Most of the organizations are doing. Some organizations are going to do it. But the next step of warranty management is through cognitive, where you will learn it. You learn more, and you make sure that you learn 21 times. That's a number generally being said, right? And you make sure that you eliminate the cost of warranty slowly. Again, dream world, one day there'll be no warranty cost operations, right? Hard to achieve, but I'm sure we will achieve that too. The last one is a very interesting topic. It is workforce reimagined. How do you optimize resources in a cognitive era, automation era in manufacturing? So there are two folks interacting. So there is an engineer, 30 years of experience, and there is a millennial who is not looking at that person and continuously chatting. So the engineer is thinking he's chatting or she's chatting. So the engineer asks the millennial, hey, what you doing? Then he or she says, I'm actually checking what you're saying and saying that in my database I have playbook or not. So the engineer, 30 years of experience, that person says, wow, I didn't realize it. So you basically take my knowledge, you digitize it, and that's great. I should do that too. Then I may do something more effective than I'm just telling you or training you what to do. Workforce reimagined, right? It's completely getting digitized. So the last one, so that's the main theme. So in this one slide, the summary is that when we are talking about worker safety, we are doing this for one of our customers. It's how I gain insight and make sure that we have a good safety record, make sure we learn from the mistakes that what we're doing, and we make sure that we have a very good predictive control tower, war room type of a concept that, hey, when a tsunami comes, how you should react, how you should optimize resources. That I have to shift my inventory from one place to the other. At the same time, you have to be safe, right? That's the example. So there is an immense chance to productivity and expertise improvement for that. And then the last one is the energy consumption. So when you have a safety mechanism more cognitive, and why cognitive? Because now it's self-driven, self-healing. It knows when to stop, when the AC or heater needs to stop, when I should stop, have a stop gate so that the employees cannot cross the operations floor. And you are basically making it more energy consumption, betterment of the energy consumption for the buildings and facilities. It exactly sits into your optimization of the resources, because the person who was managing the building management and facility can be leveraged for some other product or other work. So that being said, I would say, this is my last slide. So the message here is that we are not cognitive there yet. So when somebody asks me, hey, what you do for IBM? The first thing I said, oh, I'm a near, Anirban, near not far. And I say that I'm a cognitive manufacturing leader. Then I quickly take a step back and think, is that right? I'm doing cognitive manufacturing? It's in the journey. So I don't want to, I want to be realistic that people are doing in that journey. And when we come back next year, I hope that you all have experienced some cognitive element. And that's the main message. It's like, it's prescriptive, predictive, and cognitive. That's a journey. We are absolutely in the predictive mode, going into cognitive. Thank you, Debbie. Thank you, everyone.